Confused between Django, Flask, and FastAPI? This video provides a complete professional comparison of the three most popular Python web frameworks. You'll learn their architecture, performance, scalability, security, ease of learning, database handling, and best use cases. By the end, you'll clearly understand which framework is best for web development, APIs, microservices, and enterprise applications in 2026. Whether you're a beginner or an experienced developer, this guide will help you choose the right tool for your project. Overview and core philosophy. Django. Django is a high-level Python web framework designed for rapid development and clean, pragmatic design. It follows the batteries included philosophy, meaning it provides almost everything needed to build a complete web application out of the box, including authentication, ORM, admin panel, templating engine, security protections, session handling, and routing. Django is ideal for large-scale applications where structure, maintainability, and development speed are priorities. It enforces conventions and project organization, which helps teams work consistently on enterprise-grade systems. Flask. Flask is a lightweight and minimal Python web framework built around simplicity and flexibility. It follows the micro-framework philosophy, meaning it only provides the essentials required for handling requests and routing, while allowing developers to choose additional libraries and tools as needed. Flask is preferred when developers want full control over application architecture, components, and dependencies. It is highly suitable for small to medium-sized applications, prototypes, APIs, and projects where customization is more important than built-in functionality. FastAPI. FastAPI is a modern, high-performance Python framework specifically optimized for building APIs with speed, scalability, and developer productivity in mind. It is based on Python type hints and automatic validation using Pydantic. FastAPI emphasizes asynchronous programming and performance comparable to Node.js and Go for API workloads. It automatically generates interactive API documentation and is particularly popular for microservices, AI backends, real-time applications, and modern cloud-native systems. Architecture and design philosophy. Django. Django follows the model view template, MVE, architectural pattern, which is closely related to the traditional MVC pattern. The framework strongly encourages a structured and standardized project layout. Models handle database operations through Django ORM. Views manage business logic and request handling, while templates manage the presentation layer. Django promotes convention over configuration, reducing decision-making overhead and helping teams maintain consistency across large applications. Because of its tightly integrated architecture, developers can quickly build secure and scalable systems without assembling multiple third-party tools manually. Flask. Flask uses a minimalistic and unopinionated architecture. Unlike Django, Flask does not force a specific project structure or development style. Developers are free to design applications according to their own architectural preferences. Flask primarily provides routing, request handling, and WSGI integration, while additional features such as database management, authentication, and form validation are added through external extensions. This flexibility makes Flask highly adaptable, but it also means developers must make more architectural decisions and carefully manage dependencies in larger projects. FastAPI. FastAPI is designed around modern API-centric architecture with strong support for asynchronous execution and type-driven development. It heavily leverages Python type annotations to define request validation, serialization, dependency injection, and API contracts. FastAPI follows a modular and scalable design that integrates naturally with async programming using ASGI instead of traditional WSGI. Its architecture is optimized for RESTful APIs, microservices, and high concurrency applications. FastAPI also automatically generates OpenAPI and Swagger documentation directly from the codebase, reducing documentation maintenance overhead and improving API performance and speed. Django offers solid and reliable performance for traditional web applications, especially those involving database-heavy operations, authentication systems, dashboards, and content management platforms. However, because Django includes many built-in components and primarily operates synchronously under WSGI by default, it is generally slower than lightweight or asynchronous frameworks in high concurrency scenarios. Django can still scale effectively using caching, database optimization, load balancing, and asynchronous support introduced through ASGI, but raw request throughput is not its strongest advantage compared to FastAPI. Flask delivers better raw performance than Django because of its lightweight nature and minimal built-in overhead. Since Flask only provides core web functionality, applications often execute faster for simple routes and APIs. Performance in Flask heavily depends on how developers structure the application and which extensions are integrated. While Flask can handle moderate traffic efficiently, large-scale asynchronous workloads require additional setup and tools. Flask performs well for lightweight APIs, internal tools, and applications where simplicity and flexibility matter more than maximum concurrency. FastAPI is one of the fastest Python web frameworks currently available. It is built on top of Starlet and Unicorn, utilizing ASGI and asynchronous programming for extremely efficient request handling. FastAPI can manage thousands of concurrent connections with significantly lower latency compared to traditional synchronous frameworks. Its use of modern async features allows non-blocking I/O operations, making it highly effective for real-time systems, AI services, streaming applications, and microservices. In performance benchmarks, FastAPI often approaches the speed of Node.js and Go-based API frameworks while maintaining Python simplicity and readability. Ease of learning and developer experience. Django provides an excellent developer experience for building full-featured web applications because many essential tools are already integrated into the framework. Features such as authentication, admin dashboards, ORM, migrations, and security protections reduce the need for external setup. Beginners can become productive quickly when following Django's structured approach. However, the framework's large ecosystem and strict conventions can initially feel overwhelming for developers who are new to web development. Once understood, Django significantly accelerates enterprise application development and team collaboration. Flask is widely considered one of the easiest Python web frameworks to learn because of its simplicity and minimal design. Developers can start building applications with only a few lines of code, making Flask ideal for beginners who want to understand how web frameworks operate internally. Its flexibility allows developers to gradually add only the components they need. However, as projects grow, managing architecture, dependencies, and scalability becomes more challenging because Flask does not enforce a standardized structure. The developer experience depends heavily on the developer's own architectural decisions. FastAPI offers a modern and highly productive developer experience, especially for API development. Its automatic request validation, type hint integration, dependency injection system, and auto-generated interactive documentation greatly reduce development time. Developers familiar with Python type annotations and asynchronous programming adapt quickly to FastAPI. However, beginners who are unfamiliar with async concepts, ASGI, or advanced typing may face a steeper learning curve initially. Once mastered, FastAPI enables extremely efficient development for modern backend systems and high-performance APIs, database handling, and ORM support. Django includes one of the most mature and powerful object relational mapping (ORM) systems in the Python ecosystem. The Django ORM allows developers to interact with databases using Python classes and methods instead of raw SQL queries. It supports multiple databases such as PostgreSQL, MySQL, SQLite, and Oracle. Django also provides built-in migration management, query optimization tools, model relationships, and admin integration. Its ORM is tightly connected with the framework, making database operations highly streamlined for enterprise applications and complex relational data structures. Flask Flask does not include a built-in ORM because of its micro-framework philosophy. Developers usually integrate third-party libraries such as SQLAlchemy, Peewee, or Pony ORM, depending on project requirements. SQLAlchemy is the most common choice and is highly respected for its flexibility and advanced query capabilities. While this modular approach gives developers complete control over database architecture, it also requires additional configuration and dependency management. Flask's database handling experience varies based on the tools selected by the development team. FastAPI. FastAPI itself does not provide a native ORM, but it integrates exceptionally well with modern database libraries and ORMs such as SQLAlchemy, Tortoise ORM, SQL Model, and async database drivers. FastAPI's architecture is particularly strong for asynchronous database operations, allowing efficient handling of high concurrency workloads. Combined with Pydantic models, FastAPI provides automatic validation and serialization of database responses. Developers building modern APIs often prefer FastAPI with async database layers for performance-sensitive applications and scalable microservice environments. Security features and authentication. Django is widely recognized for its strong built-in security features and enterprise-grade protections. The framework automatically includes safeguards against common web vulnerabilities such as SQL injection, cross-site scripting, XSS, cross-site request forgery, seatsrf, clickjacking, and session hijacking. Django's authentication system provides user management, password hashing, permissions, groups, and session handling out of the box. Because security is deeply integrated into the framework, developers can implement secure applications rapidly without relying heavily on external libraries. This makes Django highly suitable for financial systems, healthcare platforms, government applications, and other security-sensitive projects. Flask provides only the basic foundation for web security, leaving most authentication and protection mechanisms to external extensions and developer implementation. Developers commonly use libraries such as Flask Login, Flask JWT Extended, Flask Security, and WorkSug security utilities to build authentication systems and secure APIs. While Flask allows flexible security architectures, it requires more manual configuration and careful implementation to avoid vulnerabilities. The overall security level in Flask applications depends significantly on developer expertise and chosen third-party tools. FastAPI includes modern security capabilities specifically optimized for APIs and token-based authentication systems. It provides built-in support for OAuth 2, JWT authentication, API keys, and dependency-based security workflows. Request validation through Pydantic automatically reduces many input-related vulnerabilities by enforcing strict data schemas. FastAPI is particularly strong for secure REST APIs, microservices, and cloud-native systems. However, since FastAPI is primarily API-focused rather than a full-stack framework, developers often integrate external authentication. Scalability and enterprise usage. Django is highly scalable and has been used in many large-scale enterprise platforms, including content-heavy websites, social platforms, financial systems, and SaaS applications. Its structured architecture, reusable components, and mature ecosystem make it well-suited for long-term enterprise development. Django supports horizontal scaling through caching systems, load balancers, database replication, and asynchronous processing tools such as Celery. Because of its stability and extensive built-in features, large development teams often prefer Django for projects requiring maintainability, security, and rapid feature expansion. Flask can scale effectively when designed properly, but scalability depends more on developer architecture choices than framework conventions. Because Flask is lightweight and modular, it is often used in microservices, APIs, and custom backend systems where only specific components are required. Many companies use Flask successfully in production environments by combining it with external tools for caching, authentication, asynchronous tasks, and database management. However, As applications grow significantly, maintaining consistency and architecture across large teams may become more challenging compared to more opinionated frameworks like Django. FastAPI. FastAPI is designed with scalability and high-performance distributed systems in mind. Its asynchronous architecture enables efficient handling of massive concurrent requests with lower resource consumption. FastAPI is especially popular for microservices, AI inference servers, machine learning APIs, real-time communication systems, and cloud-native applications. The framework integrates naturally with Docker, Kubernetes, serverless deployments, and modern DevOps pipelines. Because of its speed and API-first approach, FastAPI is increasingly adopted by startups and enterprise organizations building scalable backend. Community, ecosystem, and industry adoption. Django. Django has one of the largest and most mature communities in the Python web ecosystem. Since its release in 2005, it has built a strong reputation for reliability, stability, and enterprise readiness. The framework offers extensive official documentation, a massive collection of reusable packages, and long-term community support. Django is widely adopted in industries such as finance, education, healthcare, media, and government systems. Major platforms and organizations have used Django for large-scale applications because of its mature ecosystem and proven development practices. Flask. Flask has a very large and active developer community, especially among startups, independent developers, and API-focused teams. Its simplicity and flexibility have made it one of the most widely taught Python web frameworks for beginners and intermediate developers. Flask's ecosystem relies heavily on third-party extensions, allowing developers to customize projects according to their needs. Because of its lightweight nature, Flask is commonly used for prototypes, internal tools, REST APIs, and microservices. Its broad adoption means developers can easily find tutorials, plugins, and community support resources. FastAPI. FastAPI has rapidly gained popularity since its introduction because of its modern design, high performance, and developer-friendly API features. Although newer than Django and Flask, FastAPI has built a strong and fast-growing community in areas such as cloud computing, AI infrastructure, machine learning systems, and microservices architecture. Its automatic documentation generation, async support, and strong typing system have attracted modern backend developers and DevOps teams. Many companies building AI products, real-time services, and scalable APIs increasingly choose FastAPI as their primary backend framework. Best use cases and project suitability. Django. Django is best suited for large, feature-rich web applications that require rapid development, strong security, structured architecture, and long-term maintainability. It performs exceptionally well for enterprise systems, e-commerce platforms, content management systems, educational portals, financial applications, social networks, and SaaS products. Django is ideal when teams want an all-in-one framework with built-in authentication, ORM, admin panel, and security features. Organizations that prioritize stability, scalability, and standardized development workflows often prefer Django for mission-critical systems. Flask. Flask is best suited for lightweight applications, custom backend systems, prototypes, REST APIs, internal tools, and projects requiring maximum flexibility. It is particularly useful when developers want complete control over application structure and technology choices. Flask is commonly selected for startup prototypes, small to medium applications, microservices, and educational projects where simplicity and rapid experimentation are important. Because Flask is highly modular, it is also effective for integrating specific services without the overhead of a full-stack framework. FastAPI. FastAPI is best suited for high-performance APIs, real-time systems, AI and machine learning backends, microservices, asynchronous applications, and cloud-native architectures. It excels in projects requiring high concurrency, low latency, automatic validation, and modern API standards. FastAPI is widely used for machine learning model serving, data-intensive systems, streaming services, IoT backends, and scalable distributed applications. Developers building modern API-driven systems with performance and scalability as top priorities often choose FastAPI over traditional Python frameworks. Final comparison and professional recommendation. Django. Django stands out as the most complete and opinionated framework among the three. It is best for developers and organizations that want a full-stack solution with minimal external dependencies. With built-in ORM, authentication, admin panel, and strong security defaults, Django significantly reduces development complexity for large applications. However, it can feel heavy for simple APIs or highly specialized microservice architectures. Professionally, Django is the safest choice for large-scale, monolithic applications where stability, maintainability, and rapid feature development are more important than extreme performance optimization. Flask. Flask represents flexibility and simplicity. It is not a full-stack framework, but rather a minimal foundation that allows developers to build systems exactly as they want. This makes Flask excellent for small to medium applications, prototypes, and custom architectures where control is more important than convention. However, this flexibility comes at the cost of additional engineering effort as projects grow, since developers must choose and integrate their own tools for authentication, database handling, and scaling. Professionally, Flask is best when teams want lightweight services or highly customized backend systems without framework constraints. FastAPI. FastAPI is the most modern and performance-oriented option, optimized specifically for APIs and asynchronous systems. It excels in high concurrency environments, real-time applications, and machine learning backends. With automatic validation, type hints, and built-in OpenAPI documentation, it offers both speed and strong developer experience. However, it is not intended for traditional full-stack web applications like Django. Professionally, FastAPI is the best choice for API-first development, microservices, AI or ML deployment, and cloud-native systems where performance and scalability are critical. Final professional recommendation. If you need a full web application with built-in features and long-term stability, choose Django. If you want lightweight control and flexibility for smaller services or custom systems, choose Flask. If your focus is modern APIs, microservices, AI integration, or high-performance asynchronous systems, choose FastAPI. In real-world enterprise environments, these frameworks are often used together. Django for full platforms, Flask for lightweight services, and FastAPI for high-performance API layers.